So now in this video, we'll look at a circuit that might be useful if you use lithium-ion batteries, the kind that get to 4.2 volts when they are fully charged. Lithium iron phosphate is a type of lithium-ion, but it's kind of its own type. It has different electrical properties than most lithium-ion. So, in any case, lithium-ion are the batteries that typically come in flashlights like this. This has a charger though, and probably protection circuitry built into it. So we have, if you just have like a couple cells, you don't want them to over discharge. So that would be 3 volts each. So when they're fully charged, 2 of them in series, you probably got 8.4 volts, 4.2 each. As you use them, their voltage is going to go down. Problem is when a cell gets below 3 volts, it goes through chemical changes that could be dangerous. And so you want to make sure it doesn't drop below 3 volts for either of the cells. Hopefully they're balanced the entire time. They have the equal voltage. You're not guaranteed that they are. But in any case, this should start shutting off at about 6.4 volts when there's a supply. So last video I made the NPN version. Whatever you can make with the NPN, you can make with the PNP, but polarities are opposite. Always be aware of that. Using 2N3906, any should work, but it may have a different pin layout. So emitter on top, base in the middle, and collector at the bottom. Emitter, base, collector right here. So we need a little bit of current to flow emitter to base. We're going to work our way positive to negative. Emitter to base, and then down to ground right there. So you see we got a 5.6 volt Zener diode. The V for volt is moved to the decimal spot because you might not see a decimal there. So this builds up about 5.6 volts, which is lost from the power supply. The rest of the voltage will go across this resistor. I think this one is needed to help make sure the transistor turns off so that stray signals and stuff don't get it to conduct more. But any case, you know, you may find that it works without this 10K resistor, but it's still good to have that. So we got that current pad. This is going to limit current. We don't always have much voltage to work with, so I just used a little bit lower value, 4,700 ohm resistor right there. But yeah, this needs about 5.6 volts. The emitter to the base needs about 0.6 volts. So you add them together, you got about 6.4 volts that you need for current to really flow. So it's going to flow a little bit at slightly lower voltage. So that's something to keep in mind. You may have to, add like another, maybe a forward bias diode or something to add an extra like 0.7 volts or something, if you want a higher voltage to work with. But in any case, we have 8.4 there. We can go to 7. Current's going to go down because we got less supply voltage. That's the main thing. The load, it's going to have less current go through it as the supply voltage lowers, no matter what we do. It's just a resistor limiting the current. But yeah, we should get to about 6.4, and you can see it's pretty dim. Actually, I accidentally went down to 6.3. We're simulating a discharging battery right now. So yeah, we still got some gold, but there you can see current went down a whole lot. So battery's going to last longer because current's going down. And then 6.2, we are probably, a fair bit below 1 milliamp of current that's flowing. This might actually be 1 milliamp. It's just not as sensitive as a multimeter. But definitely, probably almost no current is flowing here. So this isn't a perfect way to protect a couple of batteries, but it's far better than no protection at all. If we just put the LED and the resistor to the voltage, then it's going to keep drawing a significant amount of current right there. I can go up to 9 volts with this setup, but there you can see what we got at 5.4 volts. There'd be virtually no current at all flowing with our protection circuitry, but here you can see just going directly to the power supply, we got probably about 7 milliamps of current flowing through there. This is a 470 ohm resistor. So I use that value because it works up to 9 volts. So yeah, be aware that it's protection circuitry. It's not perfect, but as you can see there, it is far better than no protection circuitry at all. I'll put this back together before I wrap this up. So emitter there, goes to the top. And also, it's easy to put these transistors in backwards, and that's right, I lowered the supply voltage by quite a bit. It's easy to put these transistors in backwards, the emitter and the collector. I accidentally did this with the with this one right here, so because the emitter goes on the opposite side of the NPN version, polarities are opposite. But it will work backwards, but there you can see how much lower the current is. So that's how I was able to figure out it was backwards. I can't remember if it was this circuit, the last circuit, or both of them. I remember one of them. I'm like, why is current so low? And that's all it was. I had the emitter where the collector should be. So sometimes if something looks wrong, that's an easy thing you can mess up, putting the emitter and the collector in the wrong spots. The transistor will almost work the same, but there may be irregularities, that's what I'm trying to say, that you may be able to notice. And a lower current is a good sign that you have the collector and emitter backwards. So in any case, gonna end it there. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.